Hello and welcome to lesson 20.2, independent events, determining if an event is independent or not. So just so you know, independent events, we're going to figure out how numerically how to figure out if two events are independent, but usually a rule of thumb to think about when two events are independent. They're independent if one event does not affect the second event. From a two-way frequency table, and the data is showing 180 randomly selected flights that arrive in and out of an airport. So they're comparing when something's late versus on time, and a domestic flight versus an international flight. So domestic flight is within a country, and international flights are from outside that country. Just so you know. Alright, so the first question is asking us, is the event that a flight is on time independent from the event that a flight is domestic? Okay, so let's first define some what the events are. So I'm going to pick for on-time event that a flight will be on time as O, because it has the same letter, you know, and then I'll let D be the event that the flight is domestic, so it's within the country. Okay, so we're going to do this step by step. The first thing we're going to do is find the probability that the event O, something being on time, is, well, the flight being on time, right? So I'm going to go ahead and circle on time, the whole column. So this is going to be total on time versus total. The reason I'm using it twice is because total, as you can see, is 180. Just that number there. So how many total are on time? Well, I have a series of numbers I can choose from. And I could choose from 108, 54, or 162. As I can see here that total on time is actually 162. Go ahead right now and divide that out. You'll probably get a decimal, just so you know. And if you do get a decimal, like let's say it's 0.80, no, it's not 0.80, but just let's say it is, and you want to change it to a percent, we would multiply that by 100, just so you know. Okay? But go ahead and divide that out, and then multiply by 100, and what do you get? Hopefully you should have gotten 90%. That's the hope. Okay, guys? Let's go ahead and go on to the next one that we're going to do, which is the probability that if something is on time, O, that it'll be domestic. So that that would essentially be that there are blank, and of those there are blank. So there are, let's go ahead and count how many on-time flights there are, and how many of those are domestic. So again, on time. So I see I already used 162. Okay, there it is. Now I have two numbers I can choose from. And I highlighted those in yellow and in blue, so it might be helpful for you to highlight those as well. So for on time, which one of these is domestic? 108, right? So there's 108 domestic flights that are on time. Okay, out of total domestic total. Now that is blank still, so I do need to figure that out. So let's look back at our table, and I'm going to circle domestic. Okay. So this is on time and domestic. Great job. Alright, now let's see how many total flights are domestic. So again, I have two different numbers I can choose from. And I highlighted those in green and in orange. So how many are which number is our domestics total, 60 or 120? 120. All right, so take some time and go ahead and divide that out. You will probably get a decimal, just so you know. And the way we're going to change that decimal into a percent is by multiplying that by 100. So take some time right now to go ahead and calculate that. And you find that that's 90%. All right, so now we found that essentially both of them, 90%, hey, that looks like they're equal. So our on-time and domestic flights, probability of that is equal to the probability that it's on time. So the event, like I said, I spoke it already, but let's write it down. So the event that on time and domestic would be independent from the event that their flights are on time, which means that it doesn't really affect, that a flight would be on time or domestic. It doesn't really affect the one event or another. And just so you know, let's say they were not even, or I'm sorry, not equal. If we found out that the probability of O/D was not equal, and I know it is, but let's just say it wasn't, then I would find out that they're not independent. Okay, so just keep that in mind for the next one, because if we do end up where they're not equal, probabilities are not equal, that might happen. Okay, but let's go ahead and go on to part B. Alright, so for part B, again, they're giving us the same two-way table for flights that are domestic within the U.S. or within the country and international outside the country, late and on time. In this case, they're asking us, is the event of a flight being international, in this case, international, independent from a flight arriving late? Alright, so they give us some stuff to fill out. So let's say I is the event that something is independent, or I'm sorry, international, and L being for late. Alright, so we're going to find the probability that a flight is international, probability that if it's international, will it be late, and just note that we are given, again, the same total of 180. And out of 180, how many of the flights are international? So again, I'm going to circle international. And again, I'm going to go ahead and highlight. So I highlighted both numbers, 60 and 120. Which one of these is international, though? 60, right? So again, take some time right now to go ahead and calculate what that decimal value would be. And go ahead and figure out what that percent might be. Okay, that should be about 33.3% with the repeating bar over it, or you can write that as 33.33%. Either one is fine. Alright, the next thing we're going to do is find the probability something's international and late. Okay, so I'm going to go ahead and circle my late column right here. Okay. Now of these, as you can see, we're going to write what our total number of flights that are late in this column. Okay, so here I have late being 12 for domestic flights, 6 being international, and 18 total. So here, what is the total within that column that are late? 18, right? And of those lates, where do both late and international kind of cross? At about 6, right? So we're going to write this as 6 over 18. And go ahead and take some time to work that out. 6 divided by 18. you'll probably get a decimal, change it to a percent. And you should have gotten 33.3% again with a little repeating bar, or you could have written it as 33 1/3%. Now as we can see, both of this probability and that probability are equal. So then that means that this is going to be an independent event. So both of these events are independent of each other. Just keep in mind, let's say you do the problems in the packet, much like it says here. If you do end up getting it not to be equal, please make sure you're denoting that it's not independent, okay? But go ahead and try out that problem right now.